That's numbers, locus. So we need to draw. So if we see the modulus of z only on one side, this is a circle. On both sides, it's a perpendicular bisector. So this is a circle. To identify the center of the circle, we got to make it in the form z minus something. So notice that this is actually minus 3 minus 2i. We're not changing the question. Okay, so the center is 3, 2. Radius is 1. Smaller than means shade inside the circle. So we don't need to draw this or write this down, but to visualize things, I'm just going to draw it. This is the center of the circle and the radius is 1, shade inside. And this is just like y is greater than 2, because imaginary means the vertical axis, so y is greater than 2. So this is the locus. Combining those two, we get the final answer here. We have to label the center of the circle, make sure the radius is 1, and label the y-intercept of the the green line, and we shade inside the circle on top of the line. Find the greatest value for arc Z. So the Z is the line from the center, the origin, to any point in the shaded region here. So the Z can be anywhere from the origin to anywhere in this semicircle. Since we are looking for the greatest value of arc Z, that means we need to somehow make the angle theta, the argument, as big as possible. Now that happens when this Z is touching the circle. So touching the circle means this line is perpendicular to the radius of the circle. So we need to find this angle theta. So to find this angle theta, we can just look at this angle alpha first here. Okay, so if you look at the center of the circle, well, we know that this is 2 and this is 3. So this is what we mean by alpha. So that's the alpha, and we can find alpha using inverse tangent, because this is the opposite, this is the adjacent. We can find the alpha. And for this triangle now here, so notice that it's a right angle over here. So this is the angle we're trying to find. This is the beta. This is what we're trying to find here. And we know that the radius of the circle is 1. And we can find this hypotenuse from here, because this is the same common line here. The hypotenuse is, well, the square root of 2 squared plus 3 squared, which is root 13. Okay, so this is root 13, and you see this is the hypotenuse and is the opposite, so we are using sine, not tangent or cosine or something. So we use sine, we use inverse sine, we can find the angle beta. To find the angle theta, the arc Z, we're gonna need to add alpha plus beta. So just add, use a calculator, and it says here in degrees, so use at least 1 decimal place for angle in degrees. All right, that's it. I'll see you again next time.